to now earn interest year after year. That's what compounding means. So in the old days, people actually needed like simple adding machines. So compound interest was only performed annually. Before they had big computers and banks, right? They actually had to calculate people's interest. So compound interest is performed annually. Later on, with better calculators, banks started attracting business by offering interest compounded quarterly or monthly. Discrete calculations like this can be performed by dividing the interest rate by the number of times it is compounded. So I want to take my interest rate, if it was 100%, multiplying by 1, divide that by the number of months or days, and then you multiply it in the exponent. So in other words, we give you less interest for a shorter amount of time, but we compound it over and over and over. So this is the formula. You do not have to memorize it. So I will put this formula on your test. I will not put this breakdown underneath it though. So you'll need to know what goes in for these different values. A and P are also referred to future value, present value. P is usually your principal. So what are you going to put in your bank account? A stands for the amount after so many years. The 1 is what gives you back your money. R stands for interest rate. N is the number of times that you're compounding interest. So if it's annually, it's 1. Monthly would be 12. And then T is your number of years. So if you have 1 year, but you're compounding it monthly, you would do 12 times 1. If T is 2 years, but you're compounding it monthly, you'd have 24 compounds. So that's why it's T times N up here. So I just wanted to go through, how do I use this formula to calculate compound interest so that we can use it to solve problems. If I invest $4,500 at an annual interest rate of 5%, find which balance is larger. Do I want it compounded annually for 3 years or compounded quarterly for 4 years? Obviously, 4 years is going to win. I should have made them the same number of years to compare annually and quarterly, but that's okay. So I'm taking $4,500. 1 gives me my $4,500 back, plus I get my interest. So up here it says your interest rate needs to be expressed as a decimal. So 5% is 0.05. I'm compounding annually, so N is 1. So you don't really have to write that, but. And then your exponent is 1 times 3 years. So I could just write 3 up there, but I want to show you where that N is. All right, so then you can type that into a graphing calculator in one fell swoop. You don't have to do it step by step. So I need a calculator. So practice typing it in. If you did this on your phone, I think your calculator will also do this in one step, but I just type it in, 4,500 parentheses 1 plus 0.05 divided by 1 parentheses raised to the 1 times 3 power. So if you type it in all the way across and hit enter, it'll give you your new balance. A stands for your new amount. Is that what other people got? 5209.31. I would round to the nearest penny. Anyone need help typing that in? So let's see if we can set up the next one. What if I compound quarterly, but for 4 years? So I'm putting in the same amount of money, $4,500. The 1 gives me my money back. The interest rate is still 0.05 or 5%. But this time compounded quarterly, I need to divide my interest rate 4 times, right? Because they're not going to give me 5% every single compound. They're going to divide it up over the 4 different compounds. And then 4 quarters times 4 years, I'm going to get 16 compounds of my money. Does this sound familiar like you've done it before? Did you do it in Algebra 2 maybe, or did you do it in Personal Finance? It feels familiar from Algebra 2 maybe? From business? You did it in your business class? Oh, good. So see, lots of different places that you've seen compound interest. That's good. Then hopefully by the end of your high school career, it sinks in a little bit. This one obviously came out more because I had more years, but did you get 54.89? 50. Yeah, not that much more for a whole year difference, I guess. But you started with 4,500, so $300 a year-ish. Anyone need help typing it in? All right, I think I'd like you to try, see if you can set up 2 and 3 now. Do you understand where your different values go in the equation? And I can kind of come around and check for you. So I get 1 plus 0.03 raised to the 12. Like, did people, yeah, 14, 257, 61. Yeah. So, I mean, if you wanted to be, you know, whatever, if you interpreted it as how much just interest was earned, we earned what, $4,257.61 in interest because we started with 10,000 as our principal. This is the resulting amount in the account. And then this is what, 10,001 plus 0.03 compounded monthly to the 12 times 12. Are you doing okay typing in these problems? If you're going to be doing homework on your phone, you might want to practice typing one of these into your phone just to see if you actually are able to get it correctly. Oh, shoot. You what? Oh, okay. 14, 3, 26, 86. All right, we did okay on those? This is kind of looking at it in another way. So we want to figure out this time the present value, like how much would I have to invest in order to have so much like for my retirement. So this is what you look at when you're working with like a financial advisor. How much do you have now? Like what's your nest egg? How much do you want to have in 40 years for your retirement? So Donovan is offered a $50,000 signing bonus in 4 years when he graduates from college. The company that wants to hire him is expecting to earn 4% annually on its money. So how much should they invest now so that it grows to $50,000 in 4 years? So we know that we want to get to 50,000, but we don't know how much to invest right now. And then we're getting 4% annually on its money, right? And we're doing it for 4 years. I don't have to divide by 1 if it's annually, just 0.04 is fine. So I don't have to guess and check because this is actually a number that I can figure out on my calculator, 1.04 to the 4th power. And I can just take that and divide that number to the other side, right? Divide both sides by that number to get x by itself. And then x will be, how much do they have to invest? Do they have to invest $30,000? Do they have to invest $40,000? They want it to grow to 50,000 so that they have enough to pay him his signing bonus. And this is what a lot of companies will do with saving for something over time. Even like a town, they know that in 10 years they need to buy a new fire truck. They have a grant set aside that's going to grow each year through taxes and interest so that in 10 years they can buy a new fire truck or police cruiser. So they actually set aside money that grows. So 42, 740, 21. So if they set the money aside now, they kind of save $7,000, I guess. I'm not sure if you learned this in personal finance, but there is a way to calculate. All right, well, we gained $7,000, but what was the inflation rate? So there's your actual, how much interest did you actually earn when you take into account like the inflation rate over time as well? All right, here's where our friend E comes in. So we want to be able to compound continuously instead of monthly. So remember, E was the number like 2.7. So that represented doubling your money, but not only doubling it, earning it over and over and over and over and over. The interest rate comes into account. So the bank's not actually doubling your money. They're doing it based on the interest rate. So the E allows you to compound it continuously, but the interest rate is fixing their interest rate. They're not really doubling your money over time. This was that formula of how E was generated. And you can kind of see the interest formula sitting right here. Doubling your money, so 1 plus 1 over n. How many compounds do you want to the nth power? N is going to infinity. N is no longer 12 or 365, it's infinite. So we're just using E and this formula. So I will give you this formula. You have to know when to use this formula and when to use the formula on the front page for your test. But if it says the word continuous in the problem, you're using this formula. All right, so you deposit $4,000 at an interest rate of 6% compounded. It says annual interest rate is 6% and it's compounded continuously. How much do you have after 1 year? So you take $4,000, you multiply by E, and you raise E to your interest rate times your time. So for our case, it's 6% times 1 year. 4,000 times, I would use the exact value for E on your calculator. And you should be able to just type it in like that. So 4,000 E to the 0.06 power. So can everyone find the E button? It's above the divided by symbol. Did anyone not get the calculator to tell them that? 42, 47, 35. The only thing that would change for part B is your number of years. You don't have to retype the whole thing in. If you just arrow up and hit enter, you can just do 0.06 times 10 in the exponent. And it's not that much to type in, but saves you a second. You mean the dividing by? The n value? Continuously is continuously. So they're not saying it's like every nanosecond. So basically the math calculation is if we actually did it every nanosecond, n is infinite, that interest compound is 2.7. It's that magic number 2.7. So it's kind of an abstract idea, but it's compounding it more than every month, more than every day, more than every second. It's approaching the number 2.7 as a multiplier. So to me, it's kind of an abstract idea, but if you literally took that guy's example in the video we watched, they did it as 100% interest. I mean, we're only doing it at 6% interest, but he did it. If it was 100% interest, you would double your money in 1 year, right? So then he did it every month and you got a little bit more. And then he did it every day and you got a little bit more. And he squeezed it further and further, bigger ends, and it approached 2.7 as a multiplier, right? So $1 became $2.70. And so this is taking, E is now taking into account what we call continuous interest. But it's kind of an abstract idea. It's not every day. It's more than every day. And I don't know, maybe we should do some research. I don't know if banks do continuous interest. I don't think banks actually do continuous interest. I think that they do like maybe monthly. I don't know. That'd be a good question. Like, let's phone a friend, phone a bank. Does anyone even do continuous interest? I don't know. They would definitely have the computers that would do it, but would their computers update at midnight that night? You know what I mean? Checking accounts don't earn interest, so it would just be people's savings accounts or people's CDs. I don't know if you, for like investments, if you get your interest every month. So that'd be a good question. 728848, does that sound right? 728848. So then in number 6, they want you to compare 1 year of continuous interest versus 1 year of annual interest. So now we're kind of comparing apples to apples. What's the difference? If I get annual interest or continuous interest, how many dollars are we talking about at the end of the year? So this one would be that 2000 e to the 0.095. If you want to write times 1, you can write times 1. Then this one is your annual interest, which is from the front page. So see if you can use the front page equation to write out your annual interest and then compare them. So did you do 2000 e to the 0.095? So you'd have what? 219932 continuously. Annually, 2001 plus 0.095 to the first power, because it's annual, right? So dividing by 1 times 1. 1 plus 0.095. 2190. So we have a difference of what? $9. So I mean, it's not that much, but depending on how much money you have and how long you're doing it, that could add up over time. All right, and then here is calculating a future value type problem. So how much money needs to be invested initially if you're going to earn 4% continuously compounded so that in 10 years there's 150,000 in the account. 150 is your end value, right? We do not know how much we need to invest for our principal. Compounding continuously, so my E value gets put there, and it's 4% over 10 years, so 0.04 times 10 is my exponent of that. This, again, is actually just a number, right? So that's a number that you can calculate on your calculator so that you can divide whatever that number is to the other side of the equation and solve for P. So you're going to do the E value to the 0.04 times 10, and then take the 150,000 and divide by the answer. It's still quite a bit of money. Tell me if someone gets it, what that amount is. Yep. When I type mine in, I hit enter. Instead of typing that 1.49 number in again, I just start typing the next part. I want to do 150,000, and then I do divided by my answer. So that's the most exact value right there. $100,548.01. So tonight's homework, 3.3, I think has some of these application problems.